In addition to being able to handle exceptions as we've done up until now, our code can actually throw exceptions as well. And that would just be in any case where we want to signal that an error has occurred. So we might throw an exception because our code has identified something wrong with the data we're working on. Or it might even be that our code has caught an exception and wants to throw a different exception to provide more information. Now, the way we throw an exception is quite easy. We simply use the throw keyword and then provide an instance of the exception we want to throw. Now remember that exceptions are objects, so they have to be created before they can be thrown. So we just create them with the new keyword. And one of the most important things to remember when throwing an exception is that you want to be sure that you provide meaningful detail. We want to make it easy for whoever has to handle this exception to be able to figure out what was wrong. Now most exception classes provide a constructor that accepts a string message or some other detail. So you want to make sure you put as much meaningful information into that as you can. Now, as we said, sometimes we'll throw an exception because our code caught an exception and we want to add some more information to it. Well, in that situation, you want to always make sure that your new exception that you throw includes the original exception. You don't want to lose that detail. And this idea of tying one exception to another is very fundamental to the exception classes. All the exception classes have a method called init calls that will allow you to associate an exception with an instance of another exception. But this idea of associating exceptions together is so fundamental that many exception classes actually provide a constructor that will accept the other exception. So you can actually create the new exception and associate the original all in one step. Now, in most cases, when you're throwing an exception, you're going to want to throw one of the existing exception types. But it is possible to create your own custom exception types and throw those as well. Now, to really reinforce this, in most cases, you're going to want to use one of the existing exception types. But if you really have a situation where you've got something you need to provide information on that doesn't really fit one of the existing exceptions, you can define your own. But again, that's going to be one of these situations where you've got some real information, some real value to provide that you can't with the existing exception types. Now, if you do define your own custom exception type, you're generally going to inherit from the exception class. But that has an interesting implication. Remember that any exception that inherits from the exception class but not the runtime exception class is a checked exception. So the exceptions you define will become checked exceptions. The process of implementing a custom exception type is generally pretty easy. In fact, very often, the only members that your exception type will have will be constructors. And the reason for that is that most of the required functionality is inherited. The base classes have the ability for you to associate a string message and have the receiver of the exception access that message. The base classes provide things like stack traces. So you generally don't need to provide a lot more than that. I mean, there may be some situations where there's some extended error detail you might want to add. In those cases, you might have some additional getter methods to access those, but there's not going to be a lot of that. Now, when you define your custom exception type, you'll generally want to have at least two constructors. You'll have one constructor that accepts whatever the required detail is. That may be a simple string message. It may be some meaningful fields. You'll generally also want to have another constructor that accepts that same detail along with an originating exception. Again, so that if this exception is thrown in response to a different exception, they can be tied together. And you can, of course, have more constructors than that if you want to. You can have a no argument constructor. You can have whatever you need. But you'll generally have at least these two. Now, in the next clip, we'll take a look at how we can actually define a custom exception in code and how we actually throw it.